Welcome back to the next session of electrostatic potential. Friends, in the last class we discussed about the introduction of electrostatic potential and potential due to a point charge, and we arrived at an equation V is equal to plus or minus 1 by 4 pi epsilon naught Q by R. And afterwards we discussed the potential at a point due to a dipole. So now we arrived at an equation V equal to plus or minus 1 by 4 pi epsilon naught K by R square into R cap. Today we are discussing one more important topic for 3 marks, that is potential due to a system of charges. The derivation exactly resembles what we studied in the first chapter, that is electrostatic charges and fields. Friends, there we discussed where we derived 2 important derivations, that is electrostatic force due to a system of charges, electric field due to a system of charges. To arrive at the final derivation, we used a very important principle called as superposition principle. Here also in this topic we are writing many individual potentials. At the end, to arrive at the final potential or the resultant potential, just we are using the superposition principle and we are adding and arriving at the final result. Let us discuss a step-by-step process. So now, beginning, we need to consider some point charges, say Q1, Q2, Q3 at different positions. So let me consider different charges, Q1, Q2, Q3, Q1. That independency given to you, you can draw the diagram at any point, or you can put the potentials or the point charges at any point. Now, consider a point P. What I will do, so now I will consider the point P here. So to this point I will join all the point charges. Then so now at the point I want to calculate the resultant electric potential due to the system of charges. Friends, look at here. Already we know that if the source charge is positive, potential is positive. If the source charge is negative, potential is negative. Now here all the considered point charges are positive charges. So let us start our explanation with a beautiful sentence called as consider the point charges Q1, Q2, Q3, so on, Qn at a distance of R1, R2, R3, so on, Rn from the point P. Now first of all I have to write what is the potential at the point P due to the charge Q1. Potential at point P, potential at point P due to Q1. So if I write, I will get the answer V1 is equal to 1 by 4 pi epsilon naught into Q1 divided by, please keep it in mind, this Q1 distance is R1, so R1. Similarly, potential at point P, potential at point P due to Q2. So if I write this, then I will get the answer V2 is equal to 1 by 4 pi epsilon naught Q2 by R2. Similarly, potential at point P due to Q3. So if I write, I will get the answer V3 is equal to 1 by 4 pi epsilon naught Q3 by R3. Similarly, if I go with all the system of charges, so simply I will write so on, then the potential at point P due to Qn is given by Vn is equal to 1 by 4 pi epsilon naught into Qn by Rn. Then how to arrive at the total potential at the point P? Very simple. As I said, use the superposition principle. By the superposition principle, or if you use the superposition principle to arrive at the resultant potential at the point P, the superposition, by using the superposition principle, the resultant electric potential at P is, so if I write, so V is equal to V1 plus V2 plus V3 so on plus Vn. So substitute all the individual potentials, that is V1, V2, V3, so on, Vn in this equation. So what I'll get? I'll get 1 by 4 pi epsilon naught is common. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 1 by, take it outside. So if you take it outside, so inside the bracket we are left with Q1 by R1 plus Q2 by R2 plus Q3 by R3 plus so on Qn by Rn. What I have to do then? Look at this. The prefixes or subscripts going with 1, 2, 3, 4, so on n. At the same time in the denominator, the subscripts are going with again 1, 2, 3. So you can remove the summation by a symbol called as summation or sigma. So I am removing the sigma. Then instead of writing Q1, Q2, Q3, so on till Qn, just I will consider an integer, that is a n term, that is I equal to 1, starting from 1 till last term n. So the summation runs from I is equal to 1 to n. Instead of writing the specified term, that is Q1, Q2, Q3, let me write a generalized term, that is Qi divided by 1, 2, 3 is replaced by I. So it is Ri. So V is equal to 1 by 4 pi epsilon naught summation over I equal to 1 to n into Qi by Ri is the final expression or the potential at point P due to a system of charges. So first you have to describe the diagram considering the point charges Q1, Q2, Q3, so on, Qn at point P at a distance of R1, R2, R3, so on, Rn, from where? From point P. Then the potential at point P due to Q1, due to Q2, due to Q3, and so on due to Qn. Then use this proportion principle, calculate the resultant electric potential at point P using the summation and arrive at the final expression. Here friends, instead of calculating the potential at point P due to a system of charges, if this system of charges is consisting of, say now it is in the occupied or enclosed by a system, that is say volume charge density, surface charge density, if that is the case, then we should replace this charge by the relation or what we studied in the continuous charge distribution. There we studied linear charge density, surface charge density and volume charge density. Volume charge density is nothing but what? Rho into V. So Q is equal to rho V. If you substitute, we can calculate the electric potential due to system of charges enclosed by the volume. So this is one more important derivation. It is meant for 3 marks. Thank you.